Hey everyone, in this video I'm going to complete the classwork assignment, which is to prove that this triangle ADC, so this triangle right here, is congruent to this triangle ADB on the other side. Okay, what we have given to us is ABD is a right triangle, ADB is a right triangle, ABC, this whole triangle, is equilateral, and AD bisects BC. So the do nows for this week were pretty helpful in kind of guiding you, pushing you towards a proof, a structure. But let me just take what we have given and draw it out as a diagram, or make it look like something we've seen before. So I have this triangle right here, ABC, okay, A, B, C, D. The first thing we know is ADB is a right triangle, okay? Now, so this would be a right angle right here. We also know that ABC is an equilateral triangle. I asked you yesterday, equilateral triangles mean that all angles and sides are the same. What that means for us is that we can draw the sides. So that means this side is equal to this side, and that's also equal to this side, this one on the bottom. So these three sides are all equal to each other, as well as the angles. So the angles in a triangle add up to 180 degrees. So what plus what plus what is 180? What must be 60, right? If these are all the same, 60 plus 60 is 120, 120 plus 60 is 180. That means that each of these angles must also be 60 degrees. So you kind of can start to see how this can help us prove that these two halves are congruent. The one other thing we know, well actually there's two more things. One thing is that I have AD here, okay, and these triangles share a side, right? They share this middle side. Therefore, I am saying that AD is congruent to itself. I'm writing these double bars here. You see there's one tick mark, I have two tick marks here. This tells me that AD is congruent to itself. Because these triangles share this side, this will help me a lot in my proof that these are the same. They're congruent. Lastly, AD, this line bisects, it cuts in half this line right here. So this line's cut in half, therefore I know that these are all equal to each other. That AD cuts BC in half, I have CD, and I have DB. These are equal to each other, so I drew 3 tick marks to denote that. Okay, one last thing. AD bisects this angle as well, right? Because these are the same length, and that means that these angles must be the same. Definition of bisector is that it cuts this in half, right? Cuts this line in half, also cuts this angle in half, okay? That means that this is 30 degrees, and this is 30 degrees. 30 plus 30 is 60, and this bisects the angle and the line, so this is 30 and 30, okay? Now, it's very easy to see how these might be congruent, okay? Now, there's multiple things we could say. We could say, we have an S, we have an S, we have an S, we could use SSS, SSS. We have an angle, so angle, S, angle side angle, ASA. We have ASA over here, that's fine. Maybe we want to do AAS. There's like a lot of different ways we could do this. But for today, I want to do one easy one, which is SAS. Okay, I want to say that I want to use this side, I want to use this angle, and I want to use this side. That's SAS. SAS, and I can show that they're congruent. But I don't know what this angle is, but in the do now today, I asked you ADC, and ADB, what type of angle are they? So this is ADC, and this is ADB. They form a line. You should remember from our definitions and the posters on the wall that these are angles they're supplementary because this is 180 degrees, and they form a line. They're adjacent right here, they're adjacent right here, therefore they're supplementary and they're adjacent, and so these two are a linear pair. That was all you're doing now today. So these two angles are a linear pair. That means they're supplementary. Supplementary means that their sum is 180 degrees. They form a straight line. So if this sum is 180 degrees, I know this is 90. I know this must be 90. Well, 90 minus 180, 180 minus 90 is also another 90 degrees. This right angle. Are these the same? Yes, they are. I can use SAS. Okay, so, of course, really all I'm doing here is just taking what's given to me, writing it down on this shape, and then seeing what conclusions I can draw from it. And that's really all what proofs are. You just take what's given to you, you draw it, write it down somewhere, you look at it visually, you look at this picture, and now it's easy, right? There was so many ways I could do this. All I have to do is just write it out now as a 2-column proof. Let's do that. Okay, first reason is always what's given. Now what do I want to say? I want to basically say, for this, all that I care about is that AD reflects on itself. I have this side, I have this angle, which is from the right triangle, right? We know this must be right triangle that's given to us, and the bisection. So all that I care about is this right angle and this bisection. So all that I care about here, all I want to say is that ABD is a right triangle. I'm going to use it just to draw a triangle there. And AD bisects BC. Right, because these two statements, that's what I used. Because I have this angle, I know that must be 90. And this side, it must be bisecting. This stuff is just really obvious, right? It's obvious that AD is equal to itself, right? That's a true statement no matter what, so I don't care about that. Or I don't need to write it down as this proof. Or as a statement, but let me do it as statement number 2. So my first side, my first S is that AD is congruent to itself. It's equal to itself. I'll say it's congruent to itself. Right? That's what this is. It's congruent to itself, obviously. Okay, how do I say that? Well, we have this reflexive property of equality. Okay? And that's a math way of doing it. If you just want to say it's obvious, if you just want to say, like, it must be equal to itself, then that's fine. But I'm really looking for this word, the reflexive property of equality. It's an equal sign. Reflexive property of equality means that something must be equal to itself. Like A is equal to A. That's a reflexive. It's like a very obvious statement, right? But we just have to write it out because we need a reason here. I need a reason there. Okay? So that's my first S. Now let's do the other S. Okay, so let's do the other S. I see that AD bisects BC, therefore I know that CD is equal to DB. CD is congruent to DB. Why? Well, it's given to me because our AD bisects BC, but really it's just the definition of bisector. A bisector cuts scenes in half. So I'm really looking for this, that you know that definition of bisector. I'm looking for that you know that. That's my second S. I have 2 S's. Now all I need is the A. Now I can say that ADB is 90 degrees. So the measure of angle ADB is equal to 90 degrees because ABD is a right triangle. I want you to be careful here. Because you see, I have ABD and ADB. Well, how do I know which one is which? So, if you see a triangle in front of it, it's a triangle. So this is just triangle ADC, but I can also write angle ADC, and that would be this angle right here, ADC, that would be this angle right here. Okay, so depending on what you see in front of it, that can either denote a triangle or an angle. Here, I know that ABD is a right triangle, and I'm saying because of that, the measure of angle ADB, which is this right here, is 90 degrees. Okay, and that's because of the right triangle. Now, I want to say that ADC is also 90 degrees. But how? What I can do here is I can say that the measure of angle ADB plus the measure of angle ADC is equal to 180 degrees. And why is that? Because ADC and ADB form a linear pair. We know that. ADB and ADC form a linear pair. Because they're a linear pair, they are supplementary and adjacent, but because it's supplementary, their sum must be 180 degrees. Almost done here? Well, that means, like, I'm just going to plug this in. 90 plus the measure of angle ADC is equal to 180 degrees. That's the substitution property. You remember a substitute is like something that replaces, something that changes, takes the place of. The substitution property is just me plugging in 90 degrees right here. Okay, clearly the measure of angle ADC is 90 degrees because what happened? I subtracted subtraction property of equality. That tells me I can subtract any two numbers from either side and have it be the same. That's algebra 1. That's easy. It's algebra 1. But to say I solved this, to say I'm minus by 90, you must say subtraction property of equality. That's the math word for it. I subtract 90, and now I have this. Angle ADC is equal to angle ADB, therefore they're concurrent. ADB is concurrent to ADC because they're both 90. Or you can write this: the measure of ADC is equal to the measure of angle ADB. But that's obvious, right? It could just be like obvious, right? Or statement 7 and 8. Statement 7 says 90. Statement 4, 7 and 4. 7 and 4 match up, therefore they're concurrent. Finally, that's my angle. So side angle, or rather, it would be SAS. SAS. And that's it. Okay, and let me just finish this up. ADB, because of SAS. And I'm going to reference statement 2, I'm going to reference statement 8, and then I'm going to reference statement 3, because statement 2 is S, statement 8 is A, statement 3 is S. SAS. And that completes the proof. Okay, so we're done. We did it. Okay, a few takeaways. This is long, right? I am not expecting you to write to be this detailed. I know this is a lot of information to take in. It's like a whole page of work. I'm not looking for you knowing where reflexive, substitution, subtraction, properties, all these properties are. What I'm looking for is that you understand how to go from the start to the finish. Right? That you can see this and you can be like, okay, this is hard. You can see this and you can be like, okay, this is hard, but look. Once I actually write this information down, once I draw it out, look, it becomes kind of easy now. I know this must be true. All you need to do is just write it out. And that's just what you're doing here. It's always given Then you just go to the line, check each box, SAS. You just check the boxes, and then you're done, okay? So I'm not looking for that you know every exact reason or the perfect way to do it. There's multiple ways. I could have done SSS, right? I could have done SSS. I could have done that. But there's multiple ways, so it's up to you, right? I want you to come up with a path from start to finish. Because that tells me that you understand this, and that tells me that you have the critical thinking skills that I'm looking for, right? That you can think from start to finish. You can see this problem and you can think, I can think critically about this. I can do it. I can go from start to finish. I can draw a picture. I could go and write the reasons down. Okay? You must know bisector. You must know right triangle. You must know linear pair. I don't really care about the whole reason things. But what we're looking for is that you have this path. You can think about this and understand this, and you can do this on your own. Okay? So yeah, SSS, SAS. As always, multiple answers. You can do SSS, you could do many ways, but this would be the proof that I would say is exemplar. It's excellent. This is the way to go about this. Okay, so thank you, and let me know if you have any questions.